Okay, we'll look at some of the homework problems that are in section 12-5. Okay, and there are quite a bit of problems here, like 8 problems. The first one is to find the x-intercept and y-intercept for the equation y is equal to 12x plus 20. Okay, by looking at this equation, it is in what they call slope-intercept form. And slope-intercept form is in the form of y is equal to mx plus b, where m is the slope and the b is your y-intercept. Now we can easily find out what the y-intercept is because it is in slope-intercept form. So here the b is the number that's added to or subtracted from the x. In this case, that y-intercept is going to be 20. Now the only thing we need to find out is the x-intercept. And we can easily find out what the x-intercept is by letting y equal 0. So here, if we substitute 0 in for y, we'll have 0 is equal to 12x plus 20. And then we solve this equation for x by subtracting 20 on both sides. And in this case, you're going to get negative 20 is equal to 12x. And then to get the x by itself, we divide both sides of this equation by 12. Then x will be equal to negative 20 over 12. Now, here they want us to type the integer or simplified fraction. So here we need to simplify negative 20 over 12 by dividing the numerator and the denominator by 4 to get negative 5/3. So the x-intercept in this case will be simply negative 5/3. Okay. Part 2 is to write number 2 is just write the equation in slope-intercept form. And from that, identify the slope and the y-intercept. This equation, we have 4x plus 7y is equal to 5. So I'm going to work this along the side. Now what I'm going to do here is get the y by itself. Okay, because I want to write in slope-intercept form, so that means I need to get this y by itself, meaning I need to move the 4x over to where the 5 is by simply subtracting 4x on both sides. So that means I'm going to have 7y is equal to, now this is going to be negative 4x plus 5 on the left side. And then the next step will be to get that y by itself still, but here I'm going to divide each and every term by 7. So that means I'm going to have the equation y is equal to negative 4/7 x plus 5 over 7. That will be the equation that's in slope-intercept form. So here the equation in slope-intercept form is this part right here. Y is equal to negative 4/7 x plus 5 over 7. And then the next step will be to easily find out what the slope is and what the y-intercept is. Well, it's in slope-intercept form, which is, of course, y is equal to mx plus b. That means that your slope is the number that's in front of x, which is negative 4/7. So the slope here will be negative 4 over 7. And the y-intercept, of course, will be simply 5 over 7. That's the number that's added to or subtracted from. We're adding 5/7 to the negative 4/7 x, so that means that y-intercept has to be 5 over 7. All right, problem number 3 is this. Here you want to find an equation of the line containing the given pair of points and express your answer in the form of either x equal a, y is equal to b, or y is equal to mx plus b. In this case, we got the point 0, 0 and 2, 7. One of the points is the origin, the 0, 0. So that means that this equation is going to be in the form y is equal to mx, because it's one of the points is the origin. So we can say y is equal to mx is going to be in that form. Now, our x is 2. That's your x coordinate. your y coordinate is 7. So in this case, we replace the y with 7. That's going to be equal to m times x, which is 2. Now to get the m by itself, we're multiplying by 2, so we need to divide both sides by 2 to get m equal to 7 over 2. Okay, so the slope is 7 over 2, and from that we can easily go ahead and write the equation, which is going to be y is equal to just simply 7 over 2 times x. Okay, and make sure you type the x next to the fraction 7 over 2 and not in the denominator or in the numerator. Okay, take a look at this next problem. In this case here, you want to find the coordinates of two other points collinear, meaning on the same line with each of the following pairs of points. And you're given A, B, C, D, and E. All right, let's start off with part A. Which points are collinear with P, which has the ordered pair 4, 4, and Q, which is 8, 4. All right, a hint. Look at your y coordinates here. They're the same. So here, you want to pick the two ordered pairs that have the y coordinate of 4. And by looking at this, you can see here that D fits that bill because both the y coordinates are 4 with P and Q. So D would be collinear with points P and Q. All right, now part B says here, which points are collinear with P, which is negative 6, 6, and Q, which is negative 6, 7. Notice that the x coordinates are the same. They're both negative 6, so you want to pick the ordered pairs with the x coordinate both being negative 6. In this case, it'll end up being B, because R has negative 6, 4, and S also has negative 6 with 8. And then part C, which points are collinear with P, which is 0, 0, and Q, which is 0, 7. The x coordinates are zeros for P and Q, so here let's pick the x coordinate that has 0 in it as your x coordinate. R and S will satisfy that, so here we'll say D. Now part D in this answer is a little bit tricky, because you want to find which points are collinear with P, which is 0, 0, and Q, which is 3, 3. Notice the x and the y coordinates are the same. We want to pick the ordered pairs that have both the x and the y coordinate the same. Okay, 0, 0, 3, 3. So here is D, 4, 4, negative 1, negative 1. For R and S respectively. So here D would be those points that would be collinear with P and Q.